welcome to Aksharanam classes. This is Gafar sir, your physics faculty. Let's start our session. Today we will going to explain about some mathematical topic related to physics, that is called mathematical physics. So as your 9th class, this mathematical physics is must necessary to understand the physics derivations. So today we'll explain the mathematical physics for you. Understand? So simply the mathematical physics is nothing but some related to trigonometry functions, some related to formulas related to trigonometry. That what today we'll discuss. Let's start our session here. Before that, is my voice is audible? Is my voice is audible, everyone? I hope it is audible. Okay, I'll start the session here. So that is called mathematical physics. So let me write here the topic name, mathematical physics. Mathematical physics. So here before the mathematical physics, what we discussed generally trigonometry topic, I will introduce for you. What is that? Trigonometry topic I will introduce. So trigonometry here I will introduce as trigonometry. Trigonometry I will introduce. The thing that trigonometry means in here, you know very well. If you observe, trigonometry means tri means tree, metry means measurement. Simply trigonometry means we are dealing with three angles. So that is known as trigonometry. The thing is, before starting the trigonometry and the functions of the trigonometry, let me introduce some physical quantities like angle. So here the angle, let me take here angle. So what is this angle? What is this here angle? The angle means here we have two types of angles in physics. Very first one is plane angle, and the second one is what we can call solid angle. Solid angle and plane angle. So first of all, let us take here plane angle. Plane angle. Plane angle. First thing is plane angle. Second thing is solid angle. Solid angle. So here let me talk about first the plane angle. The plane angle means angle between two planes or angle between two lines, angle between two areas is known as plane angle. For example, this is a one ray and this is a one ray. This angle, this is called what? Angle between the two lines. For example, let us take this is one plane and this is another plane. This is plane A, this is plane B, and this is known, we will consider as an angle. So that angle is we consider as plane angle. Understand? Next thing is solid angle. What is mean by the solid angle here? Solid angle means, let us take here, see here, this is a cube. Let me take a cube here. Let me take a cube here. In this cube, if you observe here, this total angle at the corner, we will consider as a solid angle. Understand? The total, this is actually this is one surface, am I right? And this is another surface, and this is another surface. Three surface, the combined angle we will consider as solid angle. Got my point? And next, so what is the units for this plane angle? Plane angle units are radians. So keep it in mind. Plane angle units are what? Radian. SI unit is what? Radian. And coming to the solid angle, generally represented with omega, the units for the solid angle is steradian. Steradian. Steradian is a unit for what? Solid angle. So this is about plane angle and solid angle. And next, how do you write the formula for angles here? How do you write the formulas for angle? For that, we have some derivation part. Let us start the derivation part here. The derivation part is, look at here. Let me give some diagrams here. So let us take here, this is a 2 race or else a situation I am taking. I am taking a situation. This is one line and this is one more ray. Angle between them is how much? Theta, for example. Now here, so I'm taking this is angle theta, isn't it? Angle theta. But observe one thing, then this distance is actually called, this totally forming a sector, isn't it? This totally forming a sector. When this forming a sector, you know that this point is the center. This point is the center, and from here to here distance we will consider as radius 1. Let me take this is radius 1. Next, this distance you can take as S1, or S you can take, simply yes you can take. And next situation, let me take one more length radius. Here R1 is a radius, right? I will choose one more radius. When I take one more radius, this is representing R2. When I represent this as a R2, so but this R2 will also make some angle, right? This R2 also will make some angle. This R2 also will give some angle, isn't it? Will give some angle. But that when I give this angle, simply when I give that angle, to take this arc length as same as S, to take this is the arc length. When I am increasing the same radius, the arc length also is. Here what is the situation? I am keeping the arc length constant. When you are keeping the arc length is constant, so what is going to be the relation between this angle and this radius? So just a minute, let me erase. I'll clearly will draw here. I'll clearly draw. So the diagram is, once again I'll draw. So here this is radius R1 you can take, and this is theta 1 you can take, and this is your arc length S you can take. Similar way, one more thing, one more diagram. One more diagram is this. This is a radius R2, and this is your angle theta 2, and in this case this is S. But here among the two situations, observe one thing. Among the two situations, this is situation 1. This is situation 2. These are two situations we have. In these two situations, the arc length in the two cases is same. The arc length in two cases is same. But here, this R1 is and this R2 are not same. R1 and R2 are not same. So in this case, even this theta also are not same. Only the same quantities are what? This arc length. Now the relation I am doing here, I am finding the relation. The relation is, whenever you are increasing this angle, whenever increasing the angle, to get the same arc length, what supposed to do? You must increase the radius. Got my point here? The thing is, whenever we have the greater angle, you must increase the radius to get the same arc length. So here, in this first case, this is the theta 1 is less than, means theta 2 is greater. when you are increasing the angle by keeping the arc length constant. Arc length means this is constant. What supposed to do? You must increase this length. So that is nothing but radius. So here the thing is, when you increase the radius, what is the relation we have here? What is the relation we have? The relation is theta is inversely proportional to 1 by r. Theta is inversely proportional to 1 by r. When you increase this r, angle will be decreases. This is the relation we have. This is the first case. In the next case, let me take one more. The one more is, now I'm keeping radius constant. Now the second situation is, this is r and this is theta 1, and next one more is, this is r, this is also r. Now this is angle theta 2, let us take. Now here I'm what I'm doing here, I'm keeping now radius is are constant. When you are keeping radiuses are constant, when you change these angles, what is going to be changed? Here arc length is going to be changed. This is S1, this is S2. So in this case, I'm keeping the radius is constant. In previous case, I kept arc length is constant. In this case, I kept radius is constant. When you're increasing this angle, the arc length also increases. Before case, when you are increasing the angle, radius is decreases. That is the case we found here by keeping the arc length constant. Now in this case, by keeping the radius constant, when you increase this angle, the arc length also increases. So what is the relation between this theta and this arc length here? The theta and arc length here, that is, theta is directly proportional to arc length. So this is, you can take equation 2, and here this equation you can take as equation 1. By taking these two equations, the first equation is telling you theta is inversely proportional to 1 by r, which means that when radius increases, the angle will decreases. So that point you had from the first definition. And the second thing is what? When theta is increases, the arc length also increases. This is the 2 points we have. Now these 2 points, if you join combinedly, what you'll have if you join combinedly? The theta is directly proportional to S by R. Theta is directly proportional to S by R. Theta is directly proportional to what? S by R. So that is the point you have. Now, after remove the proportionality, theta is equal to K S by R. Now here K value is 1, then theta is equal to S by R. So how can you define this angle here? You will define the angle as the angle is equal to arc length by radius simply. So angle is equal to what? Angle is equal to what? Arc length. Arc length by radius. So this is the part our conclusion. The conclusion is what here? The arc length by radius is nothing but angle. So I hope you have understood what I explained here, that I am taking the relation between arc length and radius and theta. That is the part we did here. Got it? Better note down. Next, after that, let us take trigonometric functions. So after this, we will do trigonometric functions. Next part is trigonometry functions. So in the trigonometry function, you know very well, trigonometry function nothing but these are the functions relating the sides and angles. Trigonometry functions are nothing but relating sides and angles. So for that I will choose a right angle triangle here. I will take a right angle triangle. So let me take a right angle triangle. So, just a minute. So let me take a right angle triangle here. So imagine this is a right angle triangle. Is it appearing, this right angle triangle? So I hope it is appearing. This is a right angle triangle. In this right angle triangle, so the thing is, this you can take angle theta. This you can take angle theta. This you can take angle theta. When this angle theta, let me give names for this right angle triangle. The names are, first this is A, this is B, this is C. So this is called ABC right angle. ABC right angle triangle. In this ABC right angle triangle, this AB called. So look at here, AB called. AB is called opposite side. What is that? Opposite side. So which you will take as opposite side? Remember, keep it in mind here, this point. If this is an angle, exactly opposite side of this angle we will consider as opposite side. Next one more, and one more is BC. So BC here, BC called actually base or adjacent side. So adjacent means, generally adjacent means B side, right? So for it, this is angle. For this angle, B side is we will consider as adjacent side. And one more thing here, final one, that is AC. Here AC is called hypotenuse. Hypotenuse is AC. Now this is the way we have opposite side and adjacent side and hypotenuse. Now how do you consider here? How do you take the trigonometric function? Here we have 3 trigonometric functions. Actually we have 6, but mainly 3. Opposite of these 3 is nothing but another 3. Totally 6 we have. First I will explain the 3 first. Later I will explain that another 3. So the 3 functions. First one is sine function, sine theta. So what is mean by sine theta here? Sine theta is nothing but opposite side by adjacent. Opposite side by what? Opposite side by hypotenuse. Here opposite is AB. So first of all write down the formula. Opposite side upon hypotenuse. So here opposite side is, in this case opposite side is AB, right? AB is opposite side and hypotenuse is AC. So simply sine theta is equal to opposite side by AC. This is the formula. This is one trigonometric function. And one more trigonometric function is, look at here, one more trigonometric function, that is cos theta. Here cos theta means what? Adjacent side by hypotenuse. So what is the cos theta? Adjacent side by hypotenuse. So here adjacent side is, you know very well, the adjacent side is what? Adjacent side is BC, right? So BC by hypotenuse, you know, AC. So the cos theta function we taken as adjacent side by hypotenuse. Adjacent side is BC, hypotenuse is AC. And one more trigonometric function we have. The one more trigonometric function is tan function. Tan theta is equal to, what is the tan theta here? Tan theta is nothing but opposite side by adjacent. What is tan theta here? Opposite side by adjacent side. Simply this is your formula. So finally tan theta I can write as what I can write? Opposite is AB, adjacent side is BC. So this is how we can write the formulas for what? Trigonometry. This is the functions for trigonometric functions. So how many are there here? 3: sine function, cos function, tan function. So what is these functions are explaining you? They are explaining, or they are relating the angles and sides of the triangle. First look at here, sine function is relating the angle and opposite side and hypotenuse. And similar way, cos theta is relating angle and adjacent side and what? Hypotenuse. Same way, the tan function is relating opposite side and adjacent to the angle. This is the way we can find. And still we have 3 more functions. Those also let me discuss. So take any right angle triangle here. This is a right angle triangle. I hope it is right angle triangle. Here give the name for these triangles. The name of the triangle is ABC. Again ABC. In that ABC, this angle is representing theta. Now here just now we written sine function, right? So what is this sine function here? Sine theta is equal to what? AB by BC, right? In this case AB by BC. And similar way, one more thing is what? Cos theta is equal to BC by AC. I think I have written this is wrong. Sin theta means AB by AC, right? So next cos theta means adjacent side by hypotenuse. Adjacent side is BC, hypotenuse is AC. Similar way, tan theta is equal to AB by BC. This is your triangular functions. Now another 3 functions are exactly opposite to the sine. I mean ratio, reciprocal of sine function. That is called cosecant. Shortly cosec theta. Cosec theta is nothing but reciprocal of sine theta. So similar way, cos theta is nothing but what? Opposite side by what? Adjacent side by hypotenuse. But here one more we have, that is secant theta. Secant theta is nothing but reciprocal of cos theta. Similar way, one more we have cot theta. Cot theta is nothing but reciprocal of tan theta. So this is the relations we have. This is the relations. Once again look at here. What is the today we discussed? First thing is what is mean by angle and what is mean by plane angle, solid angle. How do you state as angle? How do you define the angle? And also we written some trigonometric function. Trigonometric function means the functions are the terms relating angles and sides of the triangle. So now let's do some questions based on these functions. So I'll show here. I'll show the concepts for you here. Yeah, now here we discussed the trigonometric functions, isn't it? We discussed the trigonometric functions. Here, see, this is your right angle triangle. In this right angle triangle, so look at here, this is AC. They given AC as a adjacent. This should be taken that angle theta, and this is BC. They took as a opposite side. Now here, look at the ratios here. According to that situation, sin theta is nothing but what? Opposite side by adjacent, actually. Okay, sin theta is nothing but what? Opposite side is adjacent. Opposite side is BC, adjacent side is what? I mean, hypotenuse is nothing but AB. So that is the part we have written here. The same way cos theta, the same way tan theta. And here reciprocal of those also here I written. Cosecant theta, secant theta, cot theta. Now see, I'll give some questions to you. Yeah. So here the questions are. Now look at this question here. In the ABC triangle ABC, angle B is 90 degrees, angle AB is 4 centimeter, angle BC is 3 centimeter. Then they're asking that match the following trigonometric ratios with their values. First, by using the given parameters, you must draw triangle first. So I'm drawing here. So look at here, this is a triangle here I'm taking. When you are taking this triangle, he said already angle B is 90 degrees. So which means that this side is B. So this angle is nothing but how much? 90 degrees. Now AB is 4 centimeter, BC is 3 centimeter. Look at here, you can take this is C and this is A. So which means that this AB is how much? How much is the AB is 4 centimeter and BC is 3 centimeter. But here we are taking this 90 angle B is a 90 degrees. So let us consider here this is theta. Okay, when you are taking this is theta. So observe that when it is theta, sin A. Actually sin A means what is the angle you must take? Sin A means you must take the angle here. So just a minute. So this is a triangle here. So here they are asking sin A. Sin A means this angle they are asking. This is theta. They have considered that is angle theta. When you consider this angle theta, this is become opposite and this is become adjacent and this AC become what? Hypotenuse. Now by using that, sin A is nothing but what? This side is you know already 4, this side is you know already 3, right? When this is 4, this is 3, by using Pythagoras theorem, we can find this as a 4 square and 3 square 25. 25 means this is become what? This is become 5, right? This is become 5. Now here sin A we can write as here 4 by, so sin A means opposite by hypotenuse kada. Opposite is 3, hypotenuse is 5. So simply which option will come here? 3 by 5. Here option G will come. Similar way, cos A. Cos A, when you are taking the cos A, adjacent side by hypotenuse. Adjacent side is 4, hypotenuse is 5. So what you will get here? Option E you will get. This value you will get. And same way cos C. So when you are taking cos C here, you have to take this as an angle. Okay, you have to take this as an angle. when you take this as an angle, cos means this is BC become adjacent, hypotenuse. BC value is for this BC value is 3 by 5, which means 3 by 5 is where again G will come. And finally tan A is nothing but opposite side by hypotenuse, adjacent. Opposite for this one I am writing here, opposite by adjacent. So tan A kada, tan A means opposite become this BC, adjacent become this AB. So that is 3 by 4. So 3 by 4, where it is 3 by 4, F you will get. So finally, what is the options we have here? This is this one has sin A, this is one have G, this one has E, and this one has again G, and this one has F. This is your options. I hope you have understood how to solve. So for today I'll stop the session. So tomorrow in the coming classes we'll explain the remaining concepts. So for today I'll taking this. Bye children.